Yeah.
Go with part 2. Okay, so in this one, it's sort of well, it's still about identity and authentication, things like that, but it's looking at the role of OpenID Connect and OAuth 2 and how it fits in with federation. And so I sort of base this around some challenges. Number one is what we want to be able to do is manage secure access to resources regardless of where the resources are physically located. So the resource might be sort of sitting in a data center somewhere. It might be sitting in your on-prem environment. It might be sitting in a private cloud. It might be sitting in a public cloud. And what we want to do is have SSO, secure access to the resource, regardless of where it is. And also regardless of which security realm it's in. So we're going to look at how challenge 1 gets solved. Challenge 2 is allowing a user to give an application limited access to resources that the user owns. So very typically, it's sort of giving a sort of social media style example would be you've got your pictures on Facebook, and what you've got is a printing service that you want to print your pictures that are on Facebook, but you just want to give that printing service limited access to your resources. And challenge 3 is making it work with lots of different application types. So let's kick in straight away with challenge 1. Challenge 1, if we wanted to gain access to lots and lots of different resources, typically what happened is we ended up having multiple identities. And we had an identity on lots and lots of maybe web servers, different identity providers, and so on. And we would log in with forms authentication, and we would be authenticated against an identity store for that particular resource. Of course, that leads to a proliferation of usernames and passwords, and we end up using the same username on multiple resources, and the username, of course, probably our email, and then of course passwords get reused because we're relying on users to do the password, and the password's being reused everywhere, and then we end up with our identity distributed all over the place, and we have no idea where it is anymore, who we've signed up to, and so on. So going to the complete opposite extreme of that is on-prem AD. On-prem AD, a single source of authority, and provided you are a member of that on-prem AD and your domain join, your device's domain join, you've basically got single sign-on. And that all works beautifully. But in this day and age, what we end up with is we need to be able to work across the internet, we need to cross boundaries, and the whole thing needs to be extremely scalable. So we need something that is much more flexible, where we can stretch boundaries, define new boundaries. And to do that, we want a method of authentication which will work regardless of where the application is. So it could be on-prem, could be a partner org, could be in a cloud, public cloud, private cloud, etc. How do we authenticate it to in exactly the same way? It's on-prem, we're authenticating to it, we shift it, put it in the cloud. We keep authenticating to it because the new authentication mechanism works regardless of the physical location of the device or the resource. And then we have our users. Our users are accessing the application. Again, traditionally it was our users from our organization accessing our resource servers. Well, now what we want is people from our org to access things, from partner orgs, from customers accessing it, and of course, device is anything. So we need to be able to do that. Next question is, where are those users' identities? And those users' identities could be the primary source of their identity, could be from their own organization, they could be from a partner org, a third-party enterprise identity provider, and a really good example of that is Microsoft Azure AD, But of course, there's lots and lots of other players. There's Okta, there's Covisint, and the list gets bigger, one login. And the list is huge, number of different identity providers. And then social identity providers, this used to be used for the likes of Google, Facebook, etc. But you'll find quite a number of small shops now are using, and by small shop, I mean small offices, are using Google identities. Some of them I've even seen using Facebook identities. And somehow we need to tie all of this together. And that's the job of federation. Federation joins it all up for us. And just as a sort of general look at federation, what we have is we have our user, and our user gets called a user or a subject principal. The thing is, federation works across lots of different protocols. So we use the same name in different ways, in different situations, and then we use multiple names to mean the same thing. So it can get quite confusing. But we have our user, and what our user wants to do is access application X. What the user does is it goes to a security token service that application X trusts. And it says, please, could I have a token that will prove my authentication to application X? And the security token service says, you need to be authenticated. And that's the first job it will do, is authenticate the user. Now, that security token service may be able to authenticate the user, or it may know where to send the user to get authenticated. But ultimately, that security token service shown in this diagram is the one that is going to have to produce the token for application X, because application X trusts that security token service to issue the token. So we now get a security token, and that is digitally signed by the security token service, and that gets presented to application X. And application X will check a number of things, and I'll come to the sort of things it checks later on, but it will definitely check the signature and say, yes, I believe the security token, I trust the issuer of that security token, and therefore I will trust all of the assertions that are on that token. What assertions can go on the token? Well, you could argue anything you like. The reality is, though, whatever the security token service will allow you to put on there. And some are very, very much more flexible than others. So now what's happened is we've got a security token, we've presented it to application X, and application X uses it as proof of authentication of the user and has other assertions about the user in the form of claims on the token. Application X, where is it? Doesn't matter. It can be anywhere, and authentication will just carry on working. So if we look at the on-the-wire protocol, it looks a little bit like this. We browse to the app. The first thing the app will do is check to see if we're authenticated. How will it know we're authenticated? Well, if we've already been authenticated, we will probably have a cookie that will prove our authentication to the app. In this particular case, we're not authenticated, so it sends us off to a security token service that it trusts. The application trusts this STS. And what will happen next is we will get authenticated, and after we're authenticated, it's going to build a security token for the application, because in the redirect to the STS, we're saying, please authenticate this user for this application. So it knows the application, it can produce the security token service that's appropriate for the app, but it also, it's very importantly, returns cookies that proves the user is authenticated to the STS. Now, if that user goes to any other resource protected by that STS, it can just represent the cookies and the user doesn't have to re-authenticate. Anyway, that gets us, the security token gets sent back to the claims-aware app. Claims-aware app opens it up, validates it, returns cookies that prove you're authenticated to the app and the appropriate page. So that's the process. Notice I haven't mentioned any protocol. And regardless of the protocol, it all works in a fairly similar way. Because if it's coming from a browser, browsers can only work in particular ways. They can do gets, they can do, they can respond to redirects, they can do posts, and so we send the token back to the web app with a post. You can automate things with a bit of JavaScript and so on. But regardless of protocol, it flows in a very similar way. So the protocol is always HTTPS, so it's HTTP in a TLS tunnel. Federation protocols are very popular at one time. From the Microsoft stable was WS Federation and WS Trust. There's still quite a lot of apps around that uses those protocols. The rest of the industry pretty much went SAML, all right, and there's a huge number of SAML apps out there today. And then now, if you're building a new app, particularly if you want to authenticate to a backend web API, you'll be using OpenID Connect and OAuth 2. OpenID Connect authenticates you to a front-end service, and then when you go from that front-end service, you get a access token, which is using the OAuth 2 protocol to give you limited access to a backend API. But don't worry about the detail for that for the moment. I will come back to it very shortly. So SSO to apps, when we sign into our, we're signing into Azure, Azure will give you back a cookie, which proves you're authenticated. And while that cookie lives, you do not have to authenticate again. And the cookies can be single factor cookies, or they can be strong authentication cookies, which are a cookie that says you've been authenticated using MFA. If you went to another site that required MFA, but you only had a cookie that says you've signed in using a password, username and password, then you'll be prompted for second factor. But once you've got your cookies, you're not going to be prompted again. There's an option which is to make cookies persistent. And if you say remain signed in, you will end up with persistent cookies. Microsoft call these cookies session tokens, just to confuse things. That they're either persistent or non-persistent cookies. If they're non-persistent cookies, close the browser. They've gone. If they're persistent, they remain. Okay, a little demo, and I'm going to go to, let's see, so I have a Windows 10 VM running, and I'm going to go to Claims app. This happens to be using WS Federation Protocol. So I hit the Claims app, it says you're not authenticated, and it shot me up to the STS, as in Azure AD, to sign in. So I'm going to sign in. I'm using a hybrid user, which is a user which has on-prem identity. So the original identity is on-prem, and they've been synchronized up into Azure AD. And I've signed in to my application. And if we look at the claims coming back, this is a signed response. We can see we've got John at 5.ad.xtshub.com, Williams, John Williams in there. And so that's using WS Fed. Now let's leave that open. And let's go and try SAML. Now, I'm going to a SAML server through a proxy. And to get through the proxy, so the SAML service is on-prem maybe, and we've published it out to the internet through a proxy. To get through the proxy, I have to authenticate to Azure AD. Well, we've already authenticated, so let's give it a go. So now we're going through the proxy, and we're going to hit the SAML app. We've hit the SAML app. The SAML app has an anonymous landing page. So we've hit it, and it says, do you want to log in? Well, we weren't prompted to get through the proxy. We were authenticated automatically using the cookies. We log in here. And again, we've now come in, again, without being prompted to authenticate again. Notice, of course, I'm leaving the browser open to keep my session cookies. So I'm going to try OIDC Azure. This is OpenID Connect, OAuth 2 application. I'm going to sign in with hybrid flow. Again, I land on an anonymous page. And what it's done is it's produced me an ID token, We'll come to what that's for later. And it's also produced me a code. And the code, the ID token, is proving my identity to the front-end web server. And then I can convert the code to token. And the access token I get back, which is here, allows me to go to the back-end system with the identity of the user. Again, don't worry about the details. We'll come to that very shortly. And just to close this off, let's look at the real power. Now I've got a Windows auth application on premises, and what I'd like to be able to do is authenticate to that. Well, I can do it because I can publish it out through a proxy, and there is the Windows Azure application proxy, but equally well, you can publish it out through F5. That's supported, and we can do it in exactly the same way. So I go to Windows Auth, and it's authenticating me through the proxy, and then it's using Kerberos constrained delegation to give me Kerberos authentication against Windows, which has been published out. So I can support legacy applications. And that's the beauty of all this. So we end up, just close that off, and go back to the slide deck. We end off being able to manage secure access to resources regardless of where they're physically located. You know, any of those resources could have been absolutely anywhere. And they were in different security realms, right? Some were in the Azure AD space, some were in my on-prem AD space. So challenge number one, we can put a big tick in the box for. Now, our next challenge is allowing a user to give an application limited access to resources that they own. So this is where we go and we want to use an app, which is the Hoochie Coochie 2020 social media aggregator. Sounds good, doesn't it? So yes, let's click on it on the button and bring it all together. And the next screen prompts you with saying, okay, just fill in the details and click to get started. And what it's asking you for is your Microsoft account details, your Facebook account details, your Google, your LinkedIn, and goodness knows what else. And this was very, very typical at one time. You would trust an application with your actual credentials for different accounts. Well, I think a savvy user is thinking, how can I consent to an app having restricted access to a set of resources that I own? And this is where the OAuth 2 protocol came along. And it was designed so that it could run on lots of different application types. So we might have a website. We might have a native app running on a desktop. We might have a native app mobile app. We might have a single page app. So the protocol has got to handle all of this. And the idea is that we allow a user to authorize app 1 to access resources on their behalf, which is sitting on app 2. There'll probably be a web API through which we do it. And having done the authorization and the consenting, what happens is app 1 gets an access token. And the access token simply goes in the authentication header, and where the access token says that app 1 can have a particular set of permissions on app 2 using the identity of the user. Right? And that's what it is. So it's an authorization protocol authorizing app 1 to have limited access to app 2. Of course, that access token could be a full-blown access token. You have any type of access, but let's say it's a controlled access or a consented to access to application 2. So let's look at the components of this. And this is OAuth 2 terminology. In the core of it, we have the authorization server. And then you have a user, which is a resource owner, and they own the resources on app 2. So they control access to those resources. And then we have the resource server here, which is app 2 itself. And then what happens is we have app 1, which is the front end system, which wants to have this limited controlled access to app 2. And that front end app is called a client, right? And this is in OAuth 2 terminology. And it's identified by a client ID. Well, when Microsoft first implemented this in Azure AD, they didn't like the term client. They preferred to call it application. So what they did is not only did they call it application, but they also renamed the client ID to an application ID. And they did this. They were a little bit naughty with you know, they didn't like the name a particular standard was using. They would rename things. If you look on the wire, what do you see passing? The client ID, right? If you look in the Azure AD, what it was showing is set up the application ID. And I think it was an MVP conference I had a big go at the product team at that point, saying it's ridiculous. You have someone who really understands OAuth 2 coming to the Azure platform, and they look for the client ID and they can't find it. And what they've done now is they have application in brackets client ID. So they do actually use the correct name, but they also have the name they use. Okay, so components: resource owner, authorization server, resource server, and then this app that wants to gain access to the resource server with limited access. Now, the user logs in and authenticates to the authorization server. That's really, really important. The user is not authenticating to app 1. Right? If you want to authenticate to app 1, we'll come back and see how we can do that. They are authenticating to the authorization server, and what they're going to be asked to do is to consent to app 1 having access to the resources on app 2. And if they consent, app 1 will be issued with an access token, which will give this limited access. So app 1 has been authorized to access app 2, but the authentication is against the authorization server. It is not against app 1. So how do we register an app in Azure AD? Well, Microsoft, they started off and there was no concept of V1 and V2 endpoints. They just had you registered an app in Azure AD. The original way of registering the app is now referred to as the V1 way, and a new way is V2. There's a lot of V1 apps out there, and there's not huge compelling reasons to move to V2 unless you're using consent. But I'll come back on that. What they did is they said that what you need to do is describe, when you configure the app, the relationship between app 1 and the backend APIs that it wants to gain access to. So you statically defined the required permissions. Okay, and this is you know, when you actually said, please, can I have an access token to app 2? What you do is you get an access token back to app 2 with whatever was statically defined as the permission set to app 2. So they had to be predefined. The problem with that is when the user signs in, they're not being asked to consent to, you know, sign you in. They're being consented to actually consent to everything that's been hardwired. So if you hardwire access to app 1, app 2, app 3, app 4, app 5, app 6, app 7, the poor old user is going to say, do you consent to app 1 having access to app 2 and app 3 and app 4 and app 5? And it becomes a complete nightmare. And what you end up with is a really complex consent dialogue, and the user reads it and says, I haven't got a clue, but I do want to use the application, so accept. So it's really blown away the layer of security that, you know, consent gives you. The other thing is the app developer needs to know that all the permissions the app requires right at the front when they first register the app. If they change the permission set, then a user's got to reconsent to everything again. Okay, so that was the V1 permissions. Along came Azure V2, and with Azure V2 they changed the model. So if we go back here, let's go back 2 slides actually. With this model, what you do is app 1 says, please can I have an access token to app 2? And system says, yeah, okay, you can have an access token to app 2, and these are the permissions you'll get, right? Because they've been statically defined. Right? With the V2 model, what you do is you say, please, can I have an access token with a particular scope? And the scope defines the resource you want to go to and the permission to that resource. So here we could ask for an access token with a scope of graph.windows.net/directory.read. So what we're saying is to graph.windows.net, we want directory read. And here it's saying to graph.windows.net directory write. So we are actually specifying the actual resource we want to go to and the permission on that resource. And we do that in the scope parameter. The beauty of this is you do not need to hardwire the actual permissions in advance of the permissions being requested. And we can use incremental consent. So we could start off with just signing in a user. And we could say, we could say to sign you in, we're going to ask permission to read your profile. Are you okay with that? And the user says yes. And the next thing is they sign in and they're being asked, do you consent to this? And then if the user logs out and logs back in again, they're not going to be asked for consent again because the consent is remembered. And they can carry on using the app. And they may just log in and just use it at a very superficial level. But when they want to do something more complex, so for instance, maybe reading their calendars, they can go to the calendar consolidation tab, and the app can say, if you want to use this feature, you're going to have to consent to the application reading your calendar. Are you going to be okay with that? And if you click yes to that, then they can trigger the consent request. And then you're asked for the calendar. And you go, okay to that. And now remembered is you can log in and access the calendar. So we can actually build up a really nice consent experience. So you've got this incremental, or it's referred to also as dynamic consent. If you're not using consent, there's not a huge incentive to move to V2, except this method of requesting an access token aligns more to the way that the industry has gone. So Microsoft in the V1, you requested access using a resource parameter. With V2, you request access using a scope parameter, which defines the resource you want to go to and the permission on that resource. If you want to view the user given the consent, a user can view it through their My Apps panel. Well, it's now My Applications if you look at the new UI, and you can actually revoke the consent. If an administrator wants to look, what they can do is they can look via the enterprise application permissions, and we can see what's being consented to. There are certain permissions that require admin consent. And if you want to give admin consent via the UI, then you have to statically define the required consents, because otherwise, how do you know what you're going to give permission to? So if you're going to just grant admin consent, it means the user will never be prompted. You will statically define permissions required, click grant consent, and you're done. If you want to, if a developer wants to make changes, they can change the permissions. You just click grant consent and you're done. Alternatively, If you don't want to do it through the UI, if it's V1, you still need to statically define it. But with V2, it can be incrementally done. But if it's doing a grant consent for the administrator, you would want to do it all in one go. Okay, so what I want to do is actually go back to here. I'm going to go to OIDC Azure, and I'm going to come in here, and I'm going to go with hybrid flow, and we'll sign in as our user, John. And well, I hope we will. Let's try that one. Okay, and notice no consent was required. And the reason being, consent's already been given. So let's go to My Applications, and I'm just going to go to the link. I don't have to sign in again because I've got cookies, right? And what I'm going to do is I'm going to look for this particular application, so all applications, and I'm looking for OIDC Azure, and I'm going to go in here, manage your application. And I'm going to revoke the permissions. So revoking the permissions, Microsoft always called it permissions, and they've now changed it. They used to say, no, let me revoke it while I talk about it. They used to say it would be nice if it was revoke consent, but they've used the name permissions in here. But that's what's happened. We've revoked the consent we previously gave. So let's close that off. And I'm going to go to OIDC Azure. I'm going to sign in again. And I'm going to sign in as my ordinary user. And what we should find is we get a consent. I'll make it a bit bigger so it's easier to see. This app would like to read my API data, sign you in and read your profile. Well, that one probably is no problem. This one, I don't really have a clue, but we could click accept. What I'm going to do is actually I'm going to click cancel. Notice it says just says permissions request. I'm going to click cancel on there. And what I'm going to do is go home on there. And I'm going to sign in again with hybrid flow. Oh, sorry, gone the wrong place. Let's see if we can go back here. Yeah. I'm going to sign it in with hybrid flow with admin consent. So this is going to bring up an admin consent prompt. And I obviously need to do this as an administrator. So I'm going to go in here. Just think. Hope that's right. Yeah. And what it's saying is permissions request. Again, we'll make it bigger. Permissions requested except for your organization. So if I accept these, I'm accepting on behalf of everybody. Nobody else is going to be prompted. Okay. So that gives you an idea. This is V1 statically defined. Let's close that off and let's go for a V2 app. And this is a V2 app in here. And hopefully it is anyway. There we go. What I can do is I can choose the permissions I want. So I'm going to go OpenID, which basically means log the person in. We use their profile, email, and I'm going to do calendar read. And I'm going to update that, and that's going to be the scope. So I'm going to go to graph.microsoft.com, ask for calendar read, and then OpenID, profile, and email is all about just signing the user into the application. I'm going to sign in with hybrid flow. And I'm going to go in as my user. And this time I haven't been asked for consent at all, okay? And that's because I've already if I go to my applications and have a look, and we look in OIDC Azure 2, OIDC Azure 2.19, that's the one, BC, and manage the application. And we'll see we've actually got 3 permissions to graph, read your calendar, sign you in, view your basic profile. So those permissions have already been given. Now, this is the beauty of V2 and dynamic consent. So what I can do is go home on this, and I can say, hey, hang on a minute, I also want to read your mail. So I'm going to update, so I'm asking to read the mail as well. And I'm going to sign in again. I don't keep cookies for the application in this test rig. So when I go to sign in, it will actually sign me in again. So I'm going to sign in with hybrid flow. I don't have to sign into Azure because it already has cookies, but I don't have application cookies. So we are signing into the app again. And what it's showing me now is that's not, hang on, what did I ask for? Let me just go back. Let me just check on that. I may have made a mistake there. Graph, because I'm calendar read, graph mail.read. Oh, I'm surprised at that. I expected to be asked for read your calendar. I expected to be asked for mail.read. Let me just check on that again. Let's log out, sign out. Okay, so actually let me go and clean here. And what I'm looking for is I'm going to go email, profile, OpenID. I'm going to go for calendar read, mail read, update that. And I'm going to sign in with hybrid flow. And I'm going to be prompted again to sign in as John. Oh, there it is. There's a glitch. So what it's done, it repeats what you've already given. So those were the original ones, but now without blowing away or anything else, I'm being asked to now read your mail, and so on. You can just carry on adding incremental consent, and the beauty of it is that the beauty of this is that the application can say why it needs the consent, because as you're incrementally asking for it. Right, let's go back to Auth2 consent. In terms of if we want to do authentication, this is not authentication to app 1. This access token has the user's name on it, right? But it's a token which is authorizing app 1 to have access to app 2. Because it's got the user's name on it, it was used badly and mistakenly as proof of authentication to app 1. It is not. And there were some horrible security holes. And what happened is the likes of Google and Facebook, they all wrote their own proprietary code, which finally got ratified as OpenID Connect. So with OpenID Connect, what we have is an ID token, which authenticates the user to app 1. And we have an access token, which authorizes app 1 to act on behalf of the user to the backend app 2 and the web API. This ID token is mandated to be a JSON web token. The access token, there is no standard at the moment. There's a proposal in to have it as a JSON web token, but that token can have a proprietary format. Azure AD uses a JSON web token. Google, with their APIs, actually uses a proprietary token. but I think you'll find that it will become a JSON Web Token at some point. And that's basically it. ID token, authenticating to app 1, access token is to the backend. JSON Web Token, if you look at it, what you've got is a header, you've got the body, it's all base 64 encoded, and you've got a signature. And if you base 64 decode that and view it as a JSON document, what you'll find is OAuth. This is the audience who it's for. This slide is actually slightly old, graph.windows.net. It would be graph.microsoft.com these days that would be going to. Although Windows.net still exists, graph.windows.net still exists. And you've got various other bits and pieces in the token. Token validation, absolutely essential. So when you receive a token, what the app needs to do is check the audience and say, first question, is it for me? Is it from an issuer I trust? Are the timestamps valid on it? And is the signature valid? And I've had a number of instances where signature validation has been turned off. The developer has been trying stuff, hasn't succeeded in actually signing the token correctly. So what they've done is they've disabled the signing, and they've also disabled signature validation. And well, sorry, they not, rather than disable the signing, they disabled the signature validation, and the actual app's been shipped like that. That's a huge security vulnerability, and you really need to check that tokens are being validated correctly. Now, we have an access token. So app 1 has an access token which allows it, authorizes it to act on your behalf to app 2. And we want to be able to carry on doing that for a very, very long time when the user's online and also when the user's offline. If the user's offline, if the access token expires, we can't ask the user for a new token. But the problem is, if we give the access token a really, really long lifetime, how would we ever revoke it? And that's a real challenge. So what happens is the access token has a fairly short lifetime, and in the Azure AD space, it's a 1-hour lifetime. And every 1 hour, you need to go back to the authorization server or the STS or Azure AD and say, hey, my access token's expired. I need a new one. Well, if you just went back with the access token, you wouldn't get a new one. But what you can have is a refresh token. And as part of the getting an access token, you can get a refresh token. And that refresh token effectively has an infinite lifetime. There are exceptions to it, but normally it's until revoked. So every 1 hour, I have to go back to the authorization server and say, please, can I have a new access token? And here's the refresh token. And what will happen is the refresh token is validated, and then a new access token is issued. But every time the refresh token is used, it's treated as an authentication, which means that if your policy has changed, right? So if you've got a conditional access policy that says if you're coming from the internet, you have to have MFA, within an hour of moving, while you're still remaining logged in, removing a device from maybe on-prem and to a remote location, you will actually realize that your access token was not granted with an MFA transaction, so you will be forced for this second factor authentication. So having this refresh token is actually extremely powerful. So challenge 2, allowing users to give an application limited access to resources that they own. Absolutely, definitely done. Challenge 3 is making it work across lots of different application types. So we have a browser that needs to talk and authenticate a user to a website. Well, that's easy. That's OpenID Connect, right? And we have an ID token. The website going to a back-end web API, that's easy. Again, it's an access token. Now, we can have a single page application, and that's sort of JavaScript running within the browser, right? And we need to go off and get data. Well, how do we go off and get data? Well, we're going to have to probably go to a web API, and to go to a web API, we need an access token. So that fits in there beautifully, but it's a single page app. So it's not a very trustable source. So we need to adjust the way we get an access token. If we've got a website sitting inside a data center, it can ask for an access token in a very secure way, but a single page app can't, right? And one of the reasons is in a single page app, you can't have a secret. So the application can't authenticate itself against the authorization server, where a website can have a secret. Native apps can't have secrets. So we need to handle those in a particular way. And a server app is normally an app which is going to a web API using the identity of the server. The server will probably sit in the data center and can be trusted with a secret. So we end up using access tokens. We got that scenario. And then we got another scenario where we hit a web API, and then that web API wants to go off and call another web API acting on behalf of the user who is in the original access token. So again, another complexity that we need to deal with. And the way that we acquire tokens in OAuth 2 terms and OpenID Connect terms is referred to as grants or flows. And the grants or flows have to change depending on the application type. So a website, a server app, sitting inside a data center, we can trust it with a secret. Single page, native apps, we can't trust them with secrets. So there's a classification. When we trust an app with a secret, we call it a confidential client. And it's obviously a more secure client. If we can't trust it with a secret, we refer to it as a public client. And these grants or flows are OAuth 2 terminology. They're called grants in the OAuth 2 actual standard, but quite often they're referred to as flows. There's one which is referred to as the authorization code grant, and what we get back is we get back a code in our initial interaction, and then we swap the code for an ID token, maybe an access token, and maybe a refresh token. That works beautifully if you've got a confidential client in the data center. It's possible to use it, but with a public client with no secret. However, we lose a lot of security doing that. Another way of dealing with it, this is fairly new, is to use a public client using what's called PKCE, or proof key for code exchange. And effectively, we generate a sort of pseudo secret. And that works very well with public clients. There's an implicit grant where we can ask for a token directly without a password. And that was used by single page applications, and it used to be the standard way of implementing a SPA. PKCE is now recommended for SPAs. We got resource owner credential grant. When we trust the software, we actually give the software our username and password. That probably you wouldn't want to do for anything other than first-party software. So if you had a Facebook application from Facebook themselves, you might well put your username and password into that app, and it could use resource owner password credential grant. But it's considered to be not the best, but it's only for trusted software, and it will probably be only software from first parties. And then finally, there's the client credential grant, which is where we're going from server to server communication. So lots and lots of different potential flows. How do we start the flow? Well, we go to an endpoint. And the endpoint, there are V1 endpoints, there are V2 endpoints, and there's also a discovery endpoint. And this uses a format which is .well-known/OpenID-configuration. And when you go up there, you will find the endpoints for calling the authorization service, for calling the token issuance service. And there are two sets of endpoints, one for V1 and one for V2. Hybrid flow is one of many flows, just to give you an idea. So our user hits the app. The app says, you're not authenticated. I'm going to shoot you off to Azure AD and tell you to get authenticated. And there's a redirect request, and the request says, please authenticate this user to this application and return an authorization code and maybe an ID token as well. Hybrid flow gives back an ID token and a code. We then, having authenticated the user, dealt with consent, we end up coming back a cookie that proves we're authenticated to Azure, and then we've got an access token. We've got a code and an ID token. The ID token goes back to the application along with the code, and what the application will do is use the ID token to check the identity of the user, and then the code is returned to the token endpoint to get back an access token. And we get back a new ID token, and we can also get back a refresh token. Again, depending on what we ask for, there's huge flexibility here. Once we've got the access token, the application is now authorized for access to the backend API using the identity of the user, and can get back the data and render it back in whatever way to the user. So how do we decide that we're using the V1 or the V2 endpoint? It's just literally different endpoint URLs that you go to. And just a very, very quick look at actually configuring this in Azure itself. So I'm just going into the portal, and I'm going to, in here, app registrations, and I'm actually looking at the OIDC app registration. So I can look at the overview for this, and oh, I hope I can. Come on, wakey wakey. Okay, that's better. Notice here it says application ID, and in brackets they put back client. The official term of this in terms of OAuth 2 is client ID, but Microsoft decided to rename that. So we've got the details of this. We've got the ability to set up our sign in, and then if we look at the permissions to backend APIs, what we'll see is we've got a single permission set up. This is our V2 endpoint. And we got a single permission, which is user.read, which we require to sign the user in. Beyond that, everything is asked for incrementally or dynamically. If we look at the app registration in here for OIDC Azure, you'll see that we require to actually statically define the API permissions. So in here, what we'll see when we get there is we have to statically define that we want to go to graph with user read, and we want to go to my API with read underscore data. But you know, both the V1 and the V2 are set up in the same place, and the only difference is that we go to different endpoints. Okay, so our third challenge is making it work across different application types. And yes, you can support native apps, single page apps, confidential clients, public clients, and you can basically cook up anything that you need using OpenID Connect and OAuth 2. So if you want to get into all the nitty-gritty of that and start playing around with troubleshooting and everything else, do remember the masterclasses. Do I have any questions? No, I don't, but I'm gonna, so are those permissions not based on claims defined in the access token? The permissions that, so let's just go back to this. Let me just pull this back here. So if we're looking at the if we're looking at the permissions for, this is OIDC Azure, this is V1. If I ask for an access token to graph, it will have user.read in there. If I ask for an access token to my API, it will have read_data. What I'm doing is, when I do this, let me just show you this. Where are we? If I can. Let me see if I can make this. Full screen. This is on the server side. I'm actually intercepting the back channel traffic. And with the back channel traffic, what we can see is we've got a request, which is authorization code. We're going to convert the code into a access token. And what we're asking for in here is, where are we? Yeah, we're asking for access to a particular resource. Right? So if you're working with V2 endpoints, you just use the scope. The scope is always OpenID and offline access, and that's set up there to get an ID token. But our access token here is actually defines the resource. So what permissions do we have to the access token? The only permissions we have to the access token are whatever is defined in the UI. Whereas if we're asking with V2, what we're going to do is set a scope parameter which says, I would like access to graph.windows.net with a particular permission. I hope that answers your question. And what I'm going to do is, oh, not that, that's horrible. Let's do that. Let's just go back, and I will hand it back to you, Kevin. Okay.